Okay, so a 5 kilogram block of wood has a static coefficient of 0.41 and a kinetic of 0.24 between itself and the level floor. This is key, it's level, right? Calculate the limit of static friction and the kinetic friction. Okay, so for static friction, I'm just going to go force of friction is mu static times the normal force, which is, since it's a level floor, the normal force is just the weight. So it's going to be mu static times m times g, and that's 0.41 times 5.0 kilograms times 9.81 newtons per kilogram. Okay? So 0.41 times 5 times 9.81 is 20.1105. Now, since that's all that's asking, I would round this. But normally I'm going to use that number in some other calculation, so I wouldn't dream of rounding it before I'm done with my calculations. Okay? So I'm going to leave that there. Okay, and then the force of kinetic friction. Friction kinetic is going to be mu kinetic times the normal force, right, which is the kinetic coefficient times m times g, which is 0.24, right, times 5 times 9, that's kilograms, and this is 9.81 newtons per kilogram. Okay, so 0.24 times 5 times 9.81, and I'm getting 11.772. Okay, so there we go. We've got a couple answers here. We'd have to round this guy to 12 and round that guy to 20, but otherwise we're done. Now, the one thing I haven't stressed here is that this is the maximum. This is a maximum of. If it is sliding, though, this is exactly what the kinetic friction is. Okay, so that's what it equals. This is the maximum for the kinetic friction. So here's an example of that, right? Okay, so there's by the way our two numbers. There's our maximum static friction, and there's our kinetic friction, right? Okay, so the block is at rest. You exert 15 newtons to the right to try to make it move. Draw and label all the forces acting on the block. Well, let's just see, okay? First off, 15 newtons, if it's sitting still, is not enough to make it move. So this block is going to be at rest. All the forces in all the directions are going to add up to 0. So first off, let's figure out the force of gravity. Force of gravity is m times g, right? So 5 times 9.81 is 49.05. So gravity pulls down on the box with a force of 49.05. That's gravity. Right? Okay, but the floor exerts a force upward. This is called the normal force. It's equal and opposite. So let's draw an equally long line. That's close, right? So this is the normal force. This is the force that the floor is exerting. Okay. Now we're exerting 15 newtons to the right. Oh, this is 49.05 newtons, right? We're exerting 15 newtons to the right, which is somewhat less than that. So I'm going to try to draw those forces. There we go, right? Okay. U, this is the force of U, right? This is 15 newtons, right? Now, it's not enough to break the little bonds that have formed between this and the surface there, right? And so the floor is just going to exert a force equal and opposite backwards. Okay, this is static friction. Okay, this is also 15 newtons. Okay, because remember, static friction is a limit. You haven't reached 20.1105 newtons, right? So therefore, it's not going to move. So if you exert 15 this way, it exerts 15 that way. If I exerted 16, it would be 16 that way. If I exerted 20 this way, it would go 20 that way. And if I exerted 20.1106, presumably, if it was that accurate, right, that these little bonds would break and it would start to accelerate, and this would be the relevant force. Okay, so these guys are equal. These guys are equal. Ta-da! Okay, so let's go to the next example. Okay, if the block is Initially at rest, and we exert a force of 35 newtons to the right, calculate the block's acceleration. Well, will it move? Well, 35 newtons is bigger than 20.1105, right? So therefore, yeah, it's gonna start to move, okay? So that's a force to the right, so let's draw that guy. Okay, there's 35 newtons. Okay, and as soon as it starts to move, this force is no longer relevant. This is the relevant force. It's now sliding to the right. Okay, so that's the force to the left. Okay, so there's a force of 11.772, and we got this from 0.24 times 5 times 9.81, right? Okay, so now we're all set. We can set this up as a positive force. This one's a negative force, and we just do this the way we always do, right? So we go 35 minus 11.772 equals 5 times A. And now we can solve for A, right? 35 minus 11.772. Divide that by 5. And I get 4.6456 meters per second squared is what A is equal to. Okay, so with 2 sig figs, we'd have to say that's our acceleration. Okay, now let's do a problem that's worthy of your talented and gifted status. Okay, 5 kilonewton block of wood, blah, 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 blah. We've got these things. This is our static force, our kinetic force that we already calculated in the first part. Kyle and Sally both exert a force on the block. It accelerates from rest to 5.2 meters per second over a distance of 10 meters to the right. If Kyle exerts a force of 25 newtons to the right, what force in what direction does Sally exert? Okay, so what do we have? It's moving to the right. Okay, we've got a force that Kyle's exerting of 25 newtons. Okay, so I'm going to say 25 newtons. And I'm going to make it positive, right? If it's sliding to the right, the 25 is enough to break that free, right? So this is the force that's relevant, okay? So if it's sliding right, the kinetic friction is to the left, right? So the 11.772 newtons is to the left. I'm going to make that negative. Right, and then there's another unknown force. I'm going to call this, this is the force of Sally, right? Okay, so let's draw a little picture of that guy. He's to the right or to the left, unknown force, right? That's the force that Sally's exerting. Now, do you see that we've got to solve, we've got initial velocity, final velocity, displacement, right? So we need to solve first a Suvat problem. Okay, so initial velocity is 0, final is 5.2 meters per second. Acceleration is, don't know, we'd like to know. Displacement is 10 meters, right? I'm going to use v squared is u squared plus 2as. So let's see, 5.2 squared divided by 2 divided by 10. The acceleration is 1.352. Okay, there we go. Okay, so the acceleration is this way, 1.352. Okay, so that's going to be a positive acceleration, right? Okay, so now we're all set. We can set up the world's greatest F equals ma expression. So F equals ma. The forces are positive 25, negative 11.772, and then the force that Sally's exerting, right? This is Kyle, friction, Sally, equals 5 times positive 1.352. Well, let's do this. 5 times that, 6.76. 25 minus that, 13.228. Oh my gosh, it's scandalous. It's scandalous, but It looks like she's exerting a negative force. She doesn't want it to accelerate to the right. Minus 13.228. Okay, negative, okay, so the force ends up being negative 6.468. Right, so it turns out Sally's exerting a force of about 6.5 newtons to the left. Right, Sally's like, Kyle's all like accelerating it, and Sally's like, no, 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 no. Okay. Yay. This is what we do. All right. I hope that helps.